In this video, we're going to talk about topic 18D, solving equations with logs and exponents, and we're going to do 4 problems. The first problem is right here. Now you can notice, hopefully, that we have log base 3 of a bunch of stuff equals log base 3 of a bunch of stuff. So what we can do, because they have that same base, that same log of 3, is we can basically ignore it, and we can just say 3x plus 5 equals 2x plus 4. So we're just setting the argument part, the stuff that's in parentheses, equal to each other. And now we want to solve this like we would any old equation that we learned how to do forever ago. And it just takes a little bit of sort of dialing back to do this. So we want to subtract the 2x on both sides, get x plus 5 equals 4, and then subtract the 5 on both sides so that we end up with x equals negative 1. And that's our final answer. Now we can always check our work by plugging our answer back into the original. So if I were to put negative 1 into each of these x's, I would have log base 3 of 3 times negative 1 plus 5 equals log base 3 of 2 times negative 1 plus 4. And then we can do the math in each of these parentheses. So we'll get negative 3 plus 5 is 2. And over here, negative 2 plus 4 is 2. And you can notice that I have log base 3 of 2 equals log base 3 of 2. That is totally a true statement, and this works. Problem 2 looks a little bit different because we don't actually have a log on the right side of the equation. So if that's the case, the only way to get rid of this log and isolate our x is to make this an exponential. So remember, your base is going to be in the basement, so we have a little 2 there. The thing that the log is equal to is our exponent, and then whatever is inside of the log is going to be the other side. So this is the exponential version of this equation. Now we want to do a little bit of manipulation. 2 squared is 4. And now we have a quadratic. So what that means is we need to get it equal to 0. So I'm going to subtract the 4 on both sides. And we'll have 0 equals x squared minus 3x minus 4. And I want to factor this thing. So what can multiply to be negative 4? Add to be negative 3. That is going to be a minus 4 and a plus 1. From there, I use the zero product property, set each piece equal to 0. And then I will get x equals 4. And x equals negative 1. So we got 2 answers here. Now I'm going to plug both of these back in to actually see if they work. So this is my original. If I were to put x of 4, we get 4 squared minus 3 times 4 equals 2. And just notice that these are the big parentheses. So I have log base 2 of 16 minus 12 is 4. This is a perfectly acceptable equation. If I were to rewrite it, it would be 2 to the 2 equals 4. Yes, that is absolutely true. Now let's try with the other one. So if I put negative 1 into this equation, then we get negative 1 squared minus 3 times negative 1 equals 2. Big parentheses on the outside. We'll do the inside math. Negative 1 plus 3 is 4. Again, this is going to work. We have 2 to the 2 equals 4. Totally valid answer. And we actually have 2 answers, negative 1 and positive 4. This next problem doesn't actually have a log in it right now. We have exponentials though, because we have an x in our exponents. That's what makes this exponential. What we want to do, if possible, is rewrite either one or both sides so that the base is the same. Now 2 is a small number. There's no way to rewrite that in terms of anything else, but 64 could be broken down. And if I think about it like a factor tree, I can break it down into as many things as possible. We're going to end up with a bunch of 2's. So I've got 1, 2, 3, 4, 5, 6 2's being multiplied, which means 64 is really 2 to the 6th power. So I've replaced 64 on the right side with what it's equal to, because we broke it down into all of these 2's here. Next, what I want to do is notice that I have the same base. So I have 2 to something equals 2 to something. which means that I can get rid of the 2's. I can just set the exponents equal to each other. So I took 6 minus 5x, and I took the 6, set them equal, and now I want to solve this. So I'm going to try to keep all the variables on one side. So I have a negative 5x equals 6 minus 6, which is 0, divided by negative 5, and we get x equals 0 because, yes, 0 divided by something is 0. And if we were to check this, hopefully it would work. And it totally works because 2 to the 6th is in fact 64, and this is good. All right, our last problem here has an e. This is, remember, just a constant. It's just a weird one. So e is roughly 2.718, which is kind of useful sometimes. So what we want to do to isolate our x is think about, is there any way to rewrite 5 in terms of e? And there is not. E is very unique. No way to do that. So that means we have to make this a log. Now remember, when we make it a log, we think about our base. So the base of this is e, which means this is log base e of 5 equals the exponent, because the answer to a log is always your exponent. The answer to the log is an exponent. But think about log base e. If we remember, log base e is the natural log. So this is really just saying the natural log of 5 equals 3x. I want to isolate my x, so I'm going to divide by 3. And we can actually type this whole dang thing into the calculator. So this is the natural log of 5 over 3 equals x. Make sure when you do this in your calculator, it's going to open up some parentheses. So I want you to close it after the 5 and then divide by 3. That is super duper important, because otherwise you'd be doing something like natural log of 5 divided by 3. If you don't close the parentheses, it'll assume that those are connected. We need to close the parentheses. And that's it.